Right, eventually it'll have everything that it needs from the DVD and everything that it needs in order to be able to actually boot this system under Mint. And it doesn't say, okay, I'm going to do stop testing and log you off in 5 seconds or something here. You're going to get a choice and say, okay, let's go ahead and restart and see the real thing here. Or you can still keep playing around with the system that they've got. Now, the system that they have at present is going to run slower than you would expect because it's getting stuff off of the DVD. When we brought up this terminal window, there was a binary that had to be executed. And the stuff for that binary is on the DVD. So DVD goes grind, and pulls in that image, and then it starts running. That's a whole lot slower than if you pull in an image off of the disk drive. Right, so generally you don't want to stay in that thing too long. It makes it look like this thing is running a lot slower than it's really going to. All right, so we're going to do a few more experiments, though, under the slow portion of the system. And as I mentioned, we'll do this in lab 2. If something really goes wrong, you put the DVD and put it in and tell it to boot from the DVD. Not do the install, but just boot from the DVD. And then you can mount your other file systems and see what's happened to your disk drive and so on. All right, so we'll look at that in lab 2. All right, so you can bring up another terminal shell here, right? And that one will have a different prompt associated with it because it's a non-privileged shell. I think they're giving you bash, so it's probably the $sign prompt. For a root shell, you will always get that pound sign prompt. Oh dang, I have a typo in here. The EM there was supposed to be to do an emphasis to give me italics. So we found our first mistake here. Right, so it should just say disk free. I wanted to underline the D and underline the F essentially in there. DF stands for disk free. All right, so you run the DF command, and this is what it's going to show you. There's a whole bunch of different partitions that it's got here, but the one we want to talk about here is the cow partition here, which is copy on write. Right? And this is how we wound up booting the file system from the DVD. Right? We basically pretended we had a whole disk drive stuck there in RAM. Right? So on that DVD is a whole bunch of files. And it turns out to be mostly the ones that we want to just copy onto our hard drive. But we're just running the files right from the hard drive. But the thing about a DVD is you can't write on a DVD, right? If you wanted to change one of those files or something in a directory, etc., that's not going to work on the DVD. But this thing is mounted in a special way so that even though we're using that the stuff from the DVD, if we ever want to change something, we say, oops, okay, that block where the changes needs to happen, I'm going to put that in RAM and make the changes there. We won't look at the DVD anymore for that particular block. And it does that on a block-by-block basis for every little thing that you might want to change. So as long as you have enough RAM, you could go on for ages using this. Taking some stuff off of the DVD, but anything needs to be changed now fits into RAM. So that's the idea of copy on write. Right? When it's time to write something, we take a copy of what's on the DVD and now put it in RAM, and now we can write on that part in RAM. And we remember that don't look at the DVD anymore, look at the part in RAM. All right. All right, so your root file system that you have, that's always mounted on slash essentially, and that will have all the usual Linux stuff underneath it. And you could take a look at this etc password file that's on there, and you'll find that at the very bottom of that file, this is a list of different usernames, and the first one is root, of course, and then there's other ones for admin and a mail server, etc. And the guy that you're logged on, who am I command or whatever, your username is called Mint at the moment. And that's that last entry. It's one that you can get on with no password, essentially, called Mint. And your home directory is under /home/Mint, and so on. Right? So you can look and see what's there, and you'll find a whole bunch of startup files there. And this gnome configuration subdirectory here has all the stuff that's putting up these little windows and bars and things that you've seen and showing your stuff on the desktop. And it's got all the definitions you need for that little menu that comes up and so on. That's where that stuff is actually stored. All right, so that's how that stuff actually came up. All right, now you could try to look at the structure of the disk drive. That was that picture that I had on the whiteboard here a while back. Right? And it'll say, you're not allowed to do that. Only super users can kind of look at that stuff. Right? Because with the fdisk command here, you can change partitions, delete partitions, and we don't want just anybody to be able to do that. So we could have done a sudo of fdisk to discover that. But again, I want you to try something that we know is going to fail, just so that you can see the sort of error messages and things that you get with that. Right? But we can again go into a root shell, and then the fdisk command would work after that. So if you have something like CSH, the prompt is typically a % sign. If you use TCSH, the default on this system is a greater than sign. And if you use bash or sh, the default is that. Pound sign is what you get always for root. Right? We don't want people to be confused about when they're root or not. All right, so if you do the sudo, you should have that pound sign guy, and now you can ask for dev SDA. And then I had you quit out of that. But it gives you some options to do there. If all you wanted to see was this listing that we had there is a way to do that. You can do an fdisk-l of whatever device you have, dev SDA. And then it would print this, and then you don't need to quit it. You just get the prompt back right away. But sometimes we'll want to go in there and change some things, change what kind of a partition we have and so on. But as I mentioned before, notice what it really did here. It did take those original partitions that we had here. Partition 1, 2, and 3 were all Windows things. These sorts of formatting. Right? And there's a small one up at the beginning, and then something. It used to be really, really huge here. And then at the very end, notice the start and end here are way, way bigger numbers than where this one ended at. And then it created that container from the end of this one to the beginning of that SDA3 guy there. That was the container I was talking about. And then within that container, it split from here to here, went from there to there, there to there. Split it up into two pieces. A huge one for our where we're actually putting our files, and then a smaller one for the swap space. Okay, now what's swap space for? Again, you'll learn more about this in the operating systems course. But sometimes there's not enough room in RAM to hold all the processes that need to run. At that point, we need to take some of the blocks for one of those processes and put them out on ice for a while, which means copying them into this swap partition. So we take an entire process, freeze it, and put it on ice, and give some of the other processes a bit more room to run. And you don't leave it there for too long, because otherwise somebody looks like their process just isn't moving anymore. We then bring it back in and put somebody else in the tank for a little bit. Right? So we swap things in and out when we don't have enough RAM to hold everything that's running at a given time. All right, so we need to have that. You can run your system without it, but things go certainly slower under heavy conditions if you don't have a swap partition. So by default, that happened to us, and we're not going to change it. And we let it decide how much room to use for most of the things and how much to use for swap. But if we had gotten into this, and we'll do this on the SUSE system, you can fine-tune each of those things during the installation process. All right, so there wasn't a whole lot that happened here. If we put it in this way, again, it's a little hard to see what it printed and what you printed. After that colon, it's waiting for a command. We told it to print, and after this colon, we then told it to quit. So you can duplicate more or less this stuff here. Now, the numbers may be a little bit different when you do the installation, but if they're ridiculously different, maybe we've done something a little bit funny. Okay. So they don't have to be identical. All right, we already talked about the idea of how many partitions we have and so on, and there was a limit under the old IDE systems of just 4 and how we get around that here. Now, there are ways, the fdisk option that we have there, it's something you can give it commands and change things with a command line interface. There is a graphical interface, well, the GNU partition editor, okay? gparted essentially, will give you a bar graph, kind of like what we'd seen during the initial installation there, and you can go change things and change the sizes of different things. So if you get some things wrong, that's a tool that can be used to fix it up. But many of these things are really dangerous things. You're going to lose a lot of data if you're not careful in how you apply things. As with a lot of dangerous tools there, it lets you sort of set things up without really changing things, and then you have to give it, like a go button, really make these changes now. And it warns you you're shooting yourself in the foot, and then it'll actually try to do the steps that you asked for one after the other. All right. Now, the SDA5 partition here, if you look at the cow stuff that we had before, it wasn't necessarily mounted. It's certainly not mounted on Slash. That was the currently running system, not the one that it had just created and copied stuff onto there. So again, if we sort of think about doing stuff as though we had a system that didn't quite work right now, we want to be able to go in and look at our files somewhere, even though we booted the installer and hasn't done this thing, but we would like to be able to see the files that we have. Well, we can mount partitions now that we know where things are, and we can see that SDA5 was the one that had the new Mint file system on it. We can do an ls of /mount, and this is just basically an empty directory there to serve as a mounting point, but currently there's nothing mounted on it. So let's mount now a particular partition on the hard drive on that spot. Now whatever was in the top level directory of SDA5 is now going to appear below /mount. So if you do this ls, you're going to see a ton of stuff, whereas here we saw absolutely nothing. ls mount just gave me a prompt back because there was nothing there. Now there's 20 different files or something. Well, actually they're almost all just directories. Maybe all of them completely directories. All right, so there's the new stuff that just got put in there. And indeed, we could look at tail on mount etc password. Right? Underneath the mount guy, there was a thing called etc. Underneath etc, there's your password file. Just like on Rohan, there's an etc password file. And if we do a tail on that, it'll show you the last 10 lines. And this time, rather than seeing Mint down there, you'll see that you got what you wanted here. We created a user called loser, and by default, it gives it a UID of 1000. So the same thing happens on your Macintosh. When you first create a user, you're going to be user 1000 when you first set up your laptop or a desktop on a Macintosh. And it's set up a home directory for this guy here, and its default shell is bash. We're going to change some of these things later on. Okay. All right, so if you do a diff of these two things, if you find diff on this guy and the etc password that's there right now, on that other one, the last line was Mint. On this one, it was loser, but otherwise they look relatively similar. And you should find, if you look at what you've got here, it's only using up 2% of the space here. The operating system is not a pig like Microsoft Windows is. When we put a lot of files on here, we've got a fully running system here, although we're going to add other software later on. But it really is fairly kind to your disk drive. Okay. All right, now when we reboot, rather than being under /mount here, it's going to be our / file system. How does it know that that's what's going to happen? Well, there's an etc FS system here, a file system table here. And that determines who gets mounted where. And in particular, if you look in that, you'll see something kind of like this. It's going to say this particular UUID, which happens to be SDA5, is going to be mounted as an ext4 partition on that particular mount point. So that's its mount point. Its type is ext4. And there are various options here, what you do when there's errors and so on. And when do we dump this file? Do we dump it or not? And what paths do we do the FSCK things on here? If we need to, after 6 months go by, it wants to check your file system on a boot. whether or not there's any errors in it or not. And we don't want to check maybe 16 partitions on one disk drive at the same time because they're going to kind of interfere with each other. So you do one partition on this disk drive, then you go on and do the next one, and then the next one. That's going to run faster than trying to do them all at once and have the read heads move all over the place between the different ones. So we can do that. So that's what the pass number means. Now this thing here, you can, and the way it used to be done all the time, you'd put dev SDA5 essentially here, and this is where this thing got mounted. But the problem with that was if you had like a desktop machine and now you plug your disk drive into a different place than you had to begin with, it's no longer SDA, maybe it's SDB or SDC, and we can't find the dang thing. So nowadays, when disk drives get set up, every single partition is given what's basically a random number here. They just generate some things here. It's almost impossible to get, the odds of getting two numbers being exactly the same are quite astronomical here. So it's basically a unique identifier. And this way, so okay, look through all of the partitions that you can find on this disk and find one with that identifier. Wherever that is, that's the guy that you want to boot. So that's how this way you can move your disk drives around and it'll still find the right things and mount them in the right places. Where if you say it's on the A hookup plug-in, then you gotta have the right thing plugged in exactly the right place. As long as it's found somewhere, that'll work fine. Okay? So this is kind of the old way to do it. Instead of those VUIDs, you'd say exactly which one to use. Okay, I'm going to go for maybe 5 more minutes, and then I'll give you guys a chance to maybe meet and greet a few other people and refine your groups and so on, so that hopefully you're ready to go. Just out of curiosity, anybody who's got like 4 people already yet? I think there was one group last time, so I have a group of 4 there, but only one team so far. We want to get that going fairly soon, so you guys can start on the labs next week. Do your best to find a group before we leave today. All right. Now, if you do a shutdown, it's going to automatically unmount things, but let's practice and see how to do that on the fly. It's the umount command, and notice you have to misspell unmount to get this to work. You can give it a partition to get rid of it. Now, that won't work if that file system is busy at all. We'll do this, I guess, at some other point in the lab. So I don't think we have anything sitting there. But if you were running a program on that or had a file open there or whatever, it's to say, no, I'm not going to yank the rug out from underneath these processes. Any process that's using that would prevent this mount from happening, and there's no good way to force it. It's likely to mess up your file system or mess up a running program. So you have to get rid of those programs before it would let you actually unmount these things. Now, using a file system can be something as simple as just having your current working directory be on that file system. So if we had done a CD on our little shell down into /mount something or other, that's enough, even though you're not running any command in that shell right now. That'd be enough to keep this unmount from working. Sometimes it's a little hard to find out what's preventing you from unmounting something. And again, if you're shutting down the whole system, it doesn't matter. All the processes are going to die anyway, and then there won't be anything keeping the file system from being unmounted. All right, so that's, of course, another thing you can only do as a super user. We don't let you regular users just take remove parts of the file system. All right, so finally, that's the last of the experiments I wanted you to do at that point. And so there is a little quit option here. Again, we could press the power button, it would do a shutdown. But over in where the start window would be on the old Windows systems, you have an option of doing a quit. There's also a log out, but we want to do a real quit here. And it'll bring up a little thing saying, did you really want to do that? There's a cancel button there, or we can put it in hibernate mode. Sort of remember where we were and write some stuff out to disk. Or there's also a suspend mode, and that means take what's in RAM and write it out to the swap area. And then next time when you open up your laptop or whatever, it sees, was this little code in there that said we just did a suspend. It'll take the stuff out of swap and put it back in RAM, and ta-da, you're back exactly where you were before. So hibernate takes a little bit longer to do than a suspend. Suspend, though, of course, requires you to have power running all the time, because you're keeping some stuff in memory. Oh, wait, I said that backwards, right? Hibernate is what puts things out in the swap area, so it takes a while to get it out there. And then when you start up again from that, it'll read it back into RAM. Suspend just leaves it in RAM here, and so that's not going to work if RAM doesn't have power. Okay. Well, at any rate, we're going to tell it, hey, do a reboot. You can tell it to just shut down and turn off completely, but in our case, we're going to tell it reboot. Bring it all the way down, but then let it turn off, and then a second later, it magically comes back to life and starts doing its thing again. And at that point, you really want to get rid of your whatever media is in there so that it boots from the hard drive. That's probably a pretty good stopping point for today. Okay, so we'll pick up with a few more things, and hopefully next week people will be ready to start doing their installation.